Somebody asked me about the purpose of all the components underneath the shelter here on the top of the Goldwing. This is my 75, but they're the same for 75 and 76, and there may be some changes on later years. I have not owned one, but these are the same between 75 and 76 for sure. And I thought I would take a few minutes, just maybe show some of these components, and maybe this will be helpful to somebody. But the bike is all apart, so it's easy to see everything. Easy to see everything down here by the battery as well. So I thought, oh, this will be a good time to do it. So I'm not an expert, but I'll tell you what I know about these things, and feel free to make corrections or additions down in the comments. I won't be offended. I'm not a pro. This is just my hobby. So to start out, obviously, fuse box right here. It's got a cover on it. We've got the old style glass fuses, and the inside of the fuse box cover holds a spare fuse. I'm not sure if they would have originally come with their spots for 3 fuses. Maybe it came with all 3. I don't really know. So fuse box for these components. Knock on wood, in my time messing around with these bikes, I've never had one of these fuses blow, but I'm sure it happens. We've got a regulator and a rectifier. So they work together. Here's our regulator, voltage regulator. So this works in tandem with the rectifier, which is down here by the battery. And they're part of the charging system that takes the power from the stator, which is, it's really hard to see. It's on the backside of the engine. Think of it kind of like an alternator on your car, but older technology. And it takes the AC power from your stator, turns it into DC power for the bike. And the regulator, which is here, that regulates the voltage and tries to keep it around 14.5 volts. And when your engine is running at idle, you normally, if you through a multimeter on the battery terminals here, you're going to see somewhere around 14.5 volts charging voltage while it's idling. If it's more, you got a problem. If it's less, you may have a problem as well. But these are old electrical systems, old designs, so they're not perfect. And I once had a bike where the main 30 amp fuse was causing a lot of resistance, and it actually caused, it kind of goofed things up to where the bike was overcharging. And thankfully I didn't have a problem, caught it in time, and replaced that old fuse holder with a modern fuse. So next up, something that's a little bit mysterious. It's called the reserve lighting unit. And what that does is if your headlight burns out, the low beam headlight filament, it'll switch over to the high beam filament, and it'll run it at a lower voltage. So it's kind of a safety thing to make sure you always have a headlight, even if your low beam burns out. I've had 2 of these Goldwings where the casing of this is melted and bubbled. So this one got a new old stock reserve lighting unit, and hopefully with all my connectors being cleaned and everything, hopefully this one will last me a good long time. Here we've got this resistor pack that, to be honest, I don't know exactly how this works. It's for the headlight and tail light. Some research I did said that it helps because this is kind of a dumb charging system. It's always putting out the same amount of power. It makes sure that the headlight and tail light don't take any voltage spikes that may burn the bulbs out. That's what I was able to find. And if somebody watching this knows more, or you can find something more, please share. We'd all love to learn from it. This little guy here is the turn signal flasher, just like your car has. So it's a thermoelectric switch that heats up a little metal strip, and then you hear it clicking on and off, on and off. And that makes your blinkers on the left or the right side blink on and off. down here we have a 7-volt regulator, and the job of this 7-volt regulator is to make sure that your fuel gauge and your temperature gauge are not getting overcharged or over voltage. They need 7 volts. They're very sensitive, and I've had the gauge apart for the fuel gauge, and yes, it's very small wires, so it needs 7 volts, and that's the regulator for that. It steps the 12 volts down to 7 volts. Here we've got this pack of diodes, and diodes are kind of like one-way gatekeepers for electricity, and these are more of like a safety system to make sure that you don't have the bike in second gear with the engine off and you press the starter button and the starter is able to roll your bike by driving the engine and the transmission and the rear wheel. So the job of these things is to eliminate your neutral light on the dash and make sure your clutch is in. There is a wire coming out of your clutch here that will tie into the diodes, and it all works together to make sure you don't have an accident by starting the bike in gear with the clutch out. You can have it in gear with the clutch in and it'll start even if your neutral light's off, but the diodes are what kind of controls all of that, and they're a good thing to have. That keeps things safe. Down here, it's a little tough to see. You can see that little guy with the yellow wire. That's the condenser. The condenser is a capacitor, and it helps to prevent your points, which are here. My points are open because I'm working on it. It helps to prevent them from arcing and burning and pitting too quickly. And it also, because it's a capacitor, it helps to give a stronger spark at your spark plugs. So one thing I've always read and I believe in is if you ever replace your points, the whole set of points that are here, there's 2 sets, replace the condenser as well, make sure they're all fresh. If you put in a dyna ignition, which I've done on a couple other Goldwings, the dyna replaces this whole mechanical thing here with a solid state component, and then the diode, the condenser is not needed. So I always just leave it in place with it unhooked, but you could always get rid of it and throw it out. And then next to the battery here on the other side is the starter solenoid or starter relay. And what that does is when you go and you press the start button, it's here. The start button has very light gauge wires, which could not possibly carry all the power needed to turn your starter. So the start button triggers this relay to close, and when the relay closes, it's taking full power from your battery with this heavy cable and sending it. You can't really see where it goes, but it comes out down here, and the cable goes directly into your starter. So you wouldn't want this heavy cable going up to your start button. The start button would have to be massive in order not to melt down. So the relay is used to switch the high current draw from the starter open and closed, just using very, very tiny gauge wire. So that's what I've got. I guess since we're in here, I can mention the ignition coils are here and the ballast resistor. The ignition coils take the 12 volts and they step it up. I don't know the exact figure, but they step the voltage way up and they send a very high voltage down to the spark plugs, and that's what causes your spark from the center electrode of your spark plug to ground. And without good ignition coils, you wouldn't have enough voltage to jump that gap and cause a good spark. So, and then the main wiring harness is here. I've been doing some troubleshooting, so mine's a little messy right now, but the main harness is all wrapped in tape from the factory, and it runs along the backbone here of the frame, and it's got some parts that feed down here to connect to all the goodies are on the battery box, and then it does continue up under the seat to the tail lights and turn signals. So I hope this maybe is helpful if maybe you're a novice to motorcycle electronics. This is what the Goldwing has. I love the way Honda packaged all of it right here on the one side. Everything's right here. You're not digging around the bike trying to find a component. It's all right here where you can get to it. With the shelter on the bike, it unscrews from up here. It's hinged down here, and it drops open. So it gives you pretty easy access, but I figured for a video like this, why not do it now when everything's right out in the open? So there you have it. I'm not an expert. Any other comments or anything, please feel free to leave them. I will not be offended if I goofed something up, and I'd love to learn more about it.